So we are looking at what happens to the commutation margin angle. So we already saw if alpha is greater than 60, the commutation margin angle is nothing but beta or 180 minus alpha. On the other hand, if alpha is less than 60, so let us draw the waveform. So the possible expressions for voltage across one of the valves, say valve 1 is EA minus EB or EA minus EC. So if you look at the expression for EA minus EB is minus root 2 V sin omega OT. So just mark every 60 degrees. So this is EA minus EB. So this is 0. So if you look at EA minus EC, so if I draw EA minus EC lags EA minus EB by, I can get an expression. So we saw that it lags EA minus EB by 60 degrees. So this is EA minus EC. So if I want to plot the voltage across valve 1, so we will consider the case of alpha less than 60. And of course greater than 0. Okay. So I can in fact consider even equal to 0. So I have 60 degrees here, 120 here, 180, 240, 300, 360 degrees. So if alpha is less than 60 degrees, then I have to show alpha somewhere between 0 and 60 degrees. Okay. So suppose alpha is somewhere here. So just before turning on valve 3, alpha is the instant of turning on valve 3. So that is for omega OT slightly below alpha, what is the voltage across valve 1? Voltage across valve 1 just before turning on, just before valve 3 is turned on. Valve 3 is turned on at alpha, so it is 0. So it is 0. So as soon as valve 3 is turned on, the voltage across valve 1 is EA minus EB. So it just jumps to EA minus EB. So for how long it will be EA minus EB? Up to alpha plus 120. Okay. So alpha plus 120. So where is alpha plus 120? It comes after between 120 and 180. Yeah. So alpha plus 120 is here. So up to alpha plus 120, voltage across valve 1 is EA minus EB. Then at alpha plus 120, voltage across valve 1 jumps to EA minus EC. Then it remains at EA minus EC up to alpha plus 240, that is after 240. Alpha plus 240 is between 240 and 300. So, this is alpha plus 240 degrees. So, it remains at EA minus EC. To the stage. So, after turning off, say turning off of valve 1 is by itself because current goes to 0. So, as soon as valve 3 is turned on, valve 1 goes off. So, if I look at the voltage across valve 1, after it stops conducting at, when does it stop conducting? At valve 1. When does valve 1, see we are interested in voltage across valve 1. So, as long as it is conducting, the voltage across valve 1 is 0. It is non-zero if it is not conducting, and as soon as it stops conducting, the voltage should be negative for a minimum duration. Okay. So, that minimum duration required is actually denoted by psi naught. So, a typical value of psi naught is 15 degree for 50 hertz. Okay. So, what can be, I mean what is the value of commutation margin angle? Commutation margin angle is the actual value of the angle for which the voltage across valve 1 is negative. So, this duration is decided by the 0 crossing of EA minus EC. So, in the previous case when alpha is greater than 60, it was decided by the 0 crossing of EA minus EB. Okay. So, can you get an expression for the commutation margin angle psi? 240 minus 240 degree minus alpha. Okay. So, we have two values of commutation margin angle, either it is 180 minus alpha or it is 240 minus alpha. Now, the question is, in the case of alpha being greater than 60, I had in fact a smaller value, I mean of course a smaller of course smaller or larger depends in fact on alpha. Now, the question is which one is more relevant? See whether alpha between 0 and 60 is relevant or alpha greater than 60 is relevant. See which one is more critical? Say more critical means there is a chance of this commutation margin angle, this psi, becoming less than the minimum required value. That should not be allowed. So, psi should take some minimum value, it should not go below that. So, I mean whether it is likely to happen for alpha greater than 60 or alpha less than 60? Alpha greater than 60. Now, for alpha less than 60, you see that, I mean it is, say alpha is something which can't go beyond 60. So, it is very unlikely that psi, I said a typical value is say 15 degrees, it is very unlikely that this psi will go, it is impossible in fact, it is impossible for psi to, to go below the required value. So, there is a chance of psi going below the required commutation margin angle, going below the typical value of say 15 degree, which is minimum, only in the case of alpha greater than 60. Now, that means for rectifier operation, see even for alpha greater than 60, if alpha is, I mean what is the maximum value of, in the last class we saw alpha can take any value between 0 and, what is the maximum value? 180 degree minus psi naught. Okay. So, we saw that there is one more thing, based on the sign of the average value of Vd, we could conclude that for some values of alpha, the converter operates as a rectifier. See, converter acts as a rectifier. I mean, how could we conclude this? Based on the sign of Voltage, which voltage? Which voltage? I mean, what is out? There is no output input. See, a converter has AC side, DC side. See, we talk only in terms of AC. See, by output you are trying to assume that the converter is always rectifier. Okay, so we don't use the word output or input. I mean, power can flow either from the AC side to DC side or DC side to AC side. That's why we always use the word converter. Converter is a general term. So it can operate as a rectifier or operate as a inverter. Okay, so converter operates as a rectifier if alpha is between 0 to pi by 2. See, for alpha between 0 and 90 degrees, we get positive value for what? DC side, sorry, DC side average voltage. Okay, so for the average value of the DC side voltage, I mean the average value of the DC side voltage tells us whether the converter is operating as a rectifier or inverter, because the current on the DC side is a constant current in one particular direction. So if I have positive average value, then I get rectifier operation. Now, when does it operate as inverter? So converter operates as an inverter if alpha is greater than 90 degrees. Obviously, alpha equal to 90 degrees does not correspond to either, I mean, either inverter operation or rectifier operation, because power is 0, no power. Okay. So what is the upper limit on alpha? 180 degree. So it's not 180 degree, it's 180 degree minus psi naught. Okay. So now coming back to this question of for what values of alpha the commutation margin angle expression is commutation margin angle is relevant only for what operation, whether it's rectifier or inverter. See, alpha less than 60 degrees, we got two expressions for commutation margin angle. Okay, let me write that. Commutation margin angle has two expressions. Either it is equal to 180 degree minus alpha, which is nothing but beta, or it is equal to 240 degree minus alpha. So the first expression is applicable if alpha is greater than 60 degrees, and the second expression is applicable for alpha between 0 and 60 degrees. Okay. So what is relevant for us as far as commutation margin angle is concerned is alpha greater than 60. So alpha less than 60 corresponds to rectifier operation. Please note that alpha less than 60, in fact alpha less than 90 corresponds to rectifier operation. So this actually corresponds to rectifier operation, whereas alpha greater than 60 corresponds to both rectifier and inverter, because from 60 to 90 it is rectifier and beyond 90 it is inverter. Okay. So this corresponds to both rectifier and inverter operation. Now, when does this value of psi matter, the commutation margin angle? When alpha is less than 90 or greater than 90? Yeah, it is in fact greater than 90, in fact when it is going close to 180 degrees. So that means the commutation margin angle matters for inverter operation. Okay. So psi is relevant for inverter operation. So when simplified analysis was done for the first time, that is no inductance, the notation beta itself was used for psi, because it was not necessary to have the expression for alpha less than 60, and we know that for alpha greater than 60 it is beta. So the purpose of this notation beta was because the simplified analysis with the inductance L equal to 0, beta is nothing but the commutation margin angle. Okay. So, which is actually true for inverter operation, and of course, the commutation margin angle is not relevant for rectifier operation. Is that okay?